We finish out our work here in chapter 1 by talking about unit conversions. And the unit conversions that we're going to do are kind of setting us up for future events. And what I mean by that is this idea of conversion factors, of dimensional analysis, is going to be the very backbone of a lot of what we do the rest of the semester here. So from that kind of perspective, here's what we need to kind of look at and recognize that this concept, while we may not do a whole lot of unit conversions per se for the rest of the semester, we're really practicing a technique that is going to be very useful for us for the remainder of the term. Now, a conversion factor itself is a ratio of equivalent quantities. The way I want you to think about it is that if I can tie it together with equal signs, then I can convert that into a fraction that I can use to convert from one unit set to the other. And so that's really what we're after here, and what we're all about is taking this idea of things that are tied together by equal signs, equivalent quantities, and saying I can use that because they are equal, and I can use it as a fraction to convert from one unit set to the other. And the technique that we use for that is something called dimensional analysis. Now, dimensional analysis is a common method for doing that kind of quantity conversion. What it allows us to do is, with our conversion factor in place, we are able to take a unit that we are not interested in, like kilograms, and convert it into a unit that we are interested in, like liters. And then with our application of significant figure rules, we can do our proper rounding to get the answer that we desire. And so it always falls into and kind of goes off of this framework where we take what we are interested in and we make sure to multiply it by a conversion factor that puts the unit that we are interested in getting rid of opposite the unit that we are starting with. So if that unit is in the numerator, then that unit will be in the denominator of our conversion factor. If that unit is in the denominator of our conversion factor, then we're going to get rid of it in the numerator here. That way that the units that we're interested in canceling always cancel out, and we're left with just what we're supposed to. Now, the best way to do these kinds of problems is by going through it and doing lots of examples. And so the remainder of our time today is just going to be going through and doing plenty of examples of dimensional analysis and unit conversion from a variety of different standpoints, just to help get us into the material and get us used to doing this unit conversion cancellation technique. And so we're going to start with this particular problem. What's the dose? We've got a pediatrician, and they prescribe the antibiotic amoxicillin to treat 2-year-old child suffering from an ear infection. The therapeutic dose is 75 milligrams of drug per kilogram of body mass in the patient per day. The drug is administered in the form of a flavored liquid that contains 125 milligrams per milliliter. If the child weighs 28 pounds, how many milliliters of the liquid should we give each day? Well, there's a whole lot of information in this. But what we need to do is we need to kind of break it down into the pieces of information that are useful. So let's pull out the possible pieces of information. I have 75 milligrams of amox per kilogram of mass, and that needs to be done each day. I have the liquid that is 125 milligrams of amoxicillin in every milliliter. And I have a 28-pound child. So what we should be able to look at here is we should be able to see, okay, I can see that at the very least, these two conversion factors have one thing in common. They both have a mass of amoxicillin as a common factor between them. So I know I'm going to use both of them, and I'm going to end up canceling out one with the other. Well, what I need to do is kind of draw a map here. So I've got 28 pounds of child. And I need to convert it in some way to milliliters of liquid. How do I connect those dots? Well, let's work backwards maybe. From milliliters of liquid, well, this conversion factor would give me milligrams of amoxicillin. And working backward again, I can see, okay, from milligrams of amoxicillin, I can get kilograms of body mass. So there are three conversions that I need to do here. I need to convert the pounds into kilograms. I need to convert the kilograms into milligrams. I need to convert the milligrams into milliliters. I've got two of the conversion factors already. This one here will tie together these two units, and this one here will tie together those two units. The missing link, so to speak, is how do I tie together pounds and kilograms? And for that, I'm going to need to consult some kind of a conversion table. Well, previous slide had one. Let's see if it's got pounds to kilograms on it. And sure enough, yeah, it does. I can see here that 1 kilogram of mass is equal to 2.205 pounds. So using that, 1 kilogram is equal to 2.205 pounds. With that conversion table in hand, now I can start to link it all together. So once again, starting from 28 pounds, I have 28 pounds of a child. I need to convert it. Since I have pounds in the numerator of my initial fraction, pounds needs to be in the denominator of my conversion. Kilograms will go on top. 1 kilogram is 2.205 pounds. My pounds will cancel. I'll be left with just kilograms. My second conversion, I need to go from kilograms of body mass to milligrams of amoxicillin. Conversion factor again here is 75 to 1. So the 75 goes there. The 1 goes in the denominator. Kilograms cancel. milligrams of amoxicillin are left behind. The last step, milligrams to milliliters. So milligrams of amoxicillin I want to get rid of, so I'm going to put in the denominator to get rid of it. Milliliters of liquid will be left behind. 1 milliliter of liquid is 125 milligrams of amoxicillin. And so milligrams of amoxicillin cancel. I'm left with milliliters of liquid. So now I need to break out the calculator. 28 times 75 times 1 divided by 2.205 divided by 125. My calculator says this, 7.619047, and there's a whole bunch of other digits after that, milliliters of liquid. Now we have to keep in mind our rules for significant figures here. And so how many significant figures are going to be in this answer? Well, again, remembering our rules for significant figures from the post lecture, it comes down to how many were in the measurements. So I had 2 sig figs in this conversion. I have 4 in that conversion, 2 in this conversion, 3 in that conversion. Remember, when we multiply and divide, it's all about the number of digits, not where the digits are. The fewest digits is what we're going to round to. So I have 2 instances where I only have 2 significant figures. So my final answer is only going to have 2 significant figures as well. So my first sig fig is the 7. My second is the 6. So that's where I'm going to round. 7.6, the 1 here tells us that, okay, it's less than 5. I'm going to round down. 7.6 milliliters of liquid is my correct and final answer for this problem. So in the course of a day, a child would need to take 7.6 milliliters of the medicine liquid to get the proper dosage. And just, from a practical standpoint, depending upon the age of the kid, obviously this is going to be administered twice. So it'd be split over 2 doses because any of you that are parents or have younger siblings, getting any child to take 7.5 milliliters of medicine at a time, that is not only torture, but close to impossible. So that's how you do this kind of example. So from an organizational standpoint, you need to be very thorough. Break it down piece by piece, step by step. Make sure that all of your units are canceling and that they can cancel out along the way. Then once you do, make sure that you round to the proper number of significant figures so as to avoid overestimation and overrounding. Any questions about this particular example problem before we move on to another? All right, taking your silence to mean that you're okay. Let's move on to the next example. This time we're going on a road trip. The speed limit on Interstate 70 between Denver and Kansas City is 75 miles an hour most of the way. How many hours will it take to travel the 604.9 miles between the cities? For this example, we will ignore likely stopping and changing in speed limit. So this one's a lot simpler. We need to convert our miles into hours. And there's really only one conversion for this. It's 75 miles per hour. 75 miles, so the word per is going to indicate a fraction. It means that for every 75 miles traveled, it will cost me 1 hour. Which means I can set up a conversion factor of 75 miles in 1 hour, or vice versa, depending upon the situation. So to do the conversion, 604.9 miles. Miles is in the numerator, so I want to make sure miles is in the denominator of my conversion fraction here. So 1 hour is 75 miles. My miles cancel. 604.9 divided by 75. My calculator gives me this, 8.065333, and so on, hours. Now in the chat here, I want you to do something real quick for me. Tell me how many significant figures I should round this answer to. Great work. Everybody's on the same page and it's the right page. The answer is 2. Now, some people get thrown by the fact that we have 75 miles an hour here, and we'll try to say that that's an exact value. Remember, exact values only come from counting, and you didn't count the speed here. So this 75 miles an hour is a measured value, which means I had 4 sig figs in this one and 2 in this one. So I'm going to only need 2 significant figures. So the 8 is a significant figure. The 0 is a significant figure after that decimal point. So I'm going to end up rounding this. This will be 8.1 hours. Again, the 0.1 coming from, to round that 0, I look next to it, I see a 6. 6 is greater than 5, so I need to round that one up. 8.1 hours is my answer there. All right, any questions with this one? All right, so we've got one loading up for you right now. What we want you to do here, fuel economy relates the distance a car can travel on a set amount of fuel. If a car has a rating of 41.7 miles per gallon, what will that be in kilometers per liter? So you need to convert 41.7 miles per gallon into kilometers per liter. If you have your book handy, you can go ahead and find the conversion table that you're going to need. It is table 1.3 in your textbook. Otherwise, in particular, you need to know a couple of those relationships. Let's go through the answer here. So one of the trickier things with unit conversions is when you have units in both the numerator and the denominator. So again, we're starting with our 47.1 miles in 1 gallon. Now, using these two conversion factors, we need to convert the miles into kilometers and the gallons into liters. The order in which we do them doesn't matter because, again, we're multiplying and dividing anyway. So whether we multiply by one thing first or second, it really doesn't make a difference. But we'll just go in order here. So I've got miles in the numerator, which means I need miles in the denominator of our conversion. That will allow the miles to cancel. That'll give us the kilometers that we're trying to get anyway. Now I just need to put the correct numbers in the right places, and the number travels with the unit. 1 kilometer, 0.6214 miles. And then same thing for the gallons. I need to turn the gallons into liters, but here's the tricky part. Gallons is in the denominator here. So I can't put it in the denominator here because it won't cancel, it'll actually multiply. What I need to do instead is that gallons needs to be in the numerator so that the gallons cancel out as well. And so now the numbers travel here again, 0.2642 gallons in every liter. That's going to give me the liters that I need for the denominator of the fraction. So put it all together, 41.7 multiplied by 0.2642 divided by 0.6214, my calculator gives me 17.729546 and a whole bunch of other stuff kilometers per liter. Using the chat again, tell me how many significant figures I should round to here. Right. And once again, everybody's on the right track. The answer here is 3. I have 3 significant figures, so 1, 7, and 7, those are my 3 sig figs. The 2 is going to round us down, so 17.7 kilometers per liter is going to be the answer for this problem. Right. Any questions about this problem now? All right. So let's look at one more practice problem, and then I'm going to give you some information that will be useful for you for your quiz. We have a 1960 silver quarter. It has a mass of 6.25 grams. Today, the value of silver is $17.32 per ounce. I don't know if that's actually true or not, but for the purposes of this problem, it is. Question is this: how much is the coin worth if the coin is 92% silver? Now, one piece of information that you are going to need, you need to know the conversion between grams and ounces. So again, if you've got your book handy, that's going to be table 1.3. If you don't, you need to know that 1 kilogram is equal to 35.27 ounces. So if you're having trouble getting this one started, you need to think about organization. How can you organize the information to get us to the ultimate answer? We've got grams. We need to basically convert it into dollars. So if we start putting the pieces together, working backwards, we know that we can turn ounces into dollars. Kilograms into ounces. And grams into kilograms. The only thing we haven't talked about is this 92% piece. We just got to figure out where that comes in, where that comes from, how to use it. All right, so let's talk about this problem. So from the 92% part of it, we can explore this one of two ways. We can either say, okay, well, since the coin's only 92% silver, then this 6.25 grams is not the whole thing. We need to figure out how much of the coin is actually silver and then convert. That's one way to do it. The other way to do it is we convert this into money and then we multiply it by 92% to give us the value of the silver. And so either way that you go, you're going to arrive at the same answer. To help us with the rounding, I'm actually going to save this to the end. So I'm going to start with my 6.25 grams of coin. And so the first thing I need to do is I need to convert that grams of coin into kilograms using that conversion factor, 1,000 to 1. That's going to get rid of the grams and leave me kilograms. The next thing I need to do, I need to convert the kilograms into ounces. So I'll cancel out my kilograms. I'll have ounces. And then finally, I know that I get $17.32 for every 1 ounce. And so if I put this into my calculator, 6.25 times 35.27 times 17.32 divided by 1,000. My calculator, 3 significant figures, would tell me that that 6.25 grams of silver would be worth $3.82 on this day. Now here's the thing. We haven't accounted for this 92% piece yet. That assumes that this was 100% silver. It's not. It's only 92% silver. So what I need to do is multiply it by 92%, which would be 92 over 100. So if I multiply it by 0.92, the final answer I get is actually $3.51. And not $3.82. That missing 31 cents is the cost of the impurity in the silver porter. All right, any questions with this particular example problem? All right, so a couple of things I want us to do as we're closing up for today. To the chapter 1 review here. Now, chapter 1 review here tells you, hey, this is what your homework assignment looks like, and here's how to study for the chapter 1 quiz. Here are the things that you need to know how to do. Here are the useful equations that'll be useful to you. And in this, you'll see this table right here. So this is table 1.3, not from this edition of the textbook, but actually from a previous edition of the textbook. You will be given this conversion table on quiz days. And so for the unit conversion questions in chapter 1, this will be a useful table to you. And actually, this whole sheet will be given to you. And so you do not need to memorize the conversion calculations between Fahrenheit, Celsius, and Kelvin. Those equations have been given to you. You don't need to memorize the relationships between the customary system and the SI system for units. Those are being given to you. What you do need to know is and I'll modify this slightly because I gave you slightly different list last week, but you do need to be able to know the metric system. And in particular, remember, we're going to focus between kilo and nano. So if you know the prefixes in the table between kilo and nano, and you know how to convert in between them, that's going to be useful to you. So as far as this chapter 1 homework is concerned, again, this homework guide and review is there for you. This homework is due on Friday night, and the quiz will be on Tuesday when we come back. But that's all I have for today, and I am out of time. If you have some questions or you need to talk to me, go ahead and stick around. I'm not going to make anybody late to their next meeting, so have a great day. I'll see you on Friday.